Alright, so for problem number 10, we're supposed to match. Now notice this is all log base 10 because there is no base, so that's assumed log base 10. The regular logarithm graph we graphed in the very last problem. It was a log base 3, but a log base 10 looks so very similar, and it has a vertical asymptote of 0. Notice this one has a vertical asymptote of 0, and number 1 has a vertical asymptote. 1 and 4 both have vertical asymptotes of 0. The logarithms, before without transformations, are on the positive side. So to match, A is number 4. So this is log of x. Okay? Make it look like a subscript. There we go, log of x. It's really a base 10 if there's nothing there. Now negative x is a reflection in the y-axis. So that's actually number 1. You see, that's just number 4 graph reflected right through the y-axis there, and you've got it. Now this one, if you need to rewrite this as log of negative x plus 2, that's what's really going on. It's a reflection like the one before, but now it makes it look like it's moved to the left too. But whenever you have, I'm going to write it down here below again, whenever you have a reflection with the x value, you have to factor that out before you can get your, so it's negative of x minus 2, before you can get your direction right. I know it seems crazy, but that means that we're moving to the right 2. So if we take this initial graph and move it to the right 2, that's actually transformation number, picture number 2, okay? Oh, no, wait. Look, one of them has been moved up, and that is not number 2. Number 3 is the original one. So this is number 3. This one has been moved up 1. Okay, so if you picture moving that to the right 2, you would get the one below it, number 3, and then we move all that up 1, and that gives me number 2 at the bottom. You could also just plug in points, like plug in something that makes the logarithm 1. So for instance here, you could plug in 1, and that would make that logarithm 1. So r of 1 would equal to 1 plus log of 2 minus 1 would be 1 plus log of 1. We know log of 1 is 0, so that'd be 1 plus 0, which is equal to 1. So the point 1, 1 is on this D graph, and then you see the 1, 1 right there, but it wasn't on this one, because that's 1, 0. Okay, so plugging in points is possible too. Now we're supposed to find the domain for these functions. If you'll recall, I said that a logarithm, you can only plug in positive numbers. So when you find the domain, what you really have to do is just take whatever your argument of your logarithm is. So for problem A, that's just x plus 5. And you set that greater than 0 and solve, so x is greater than negative 5. In interval notation, that would be negative 5 to infinity. Now both of these results are right. It didn't say an interval notation or inequality form, so I'm just going to leave them both there. Question B, again, you're supposed to take what's inside the logarithm, which is 3 minus x in this case, and set it to greater than 0, always greater than 0. So you could add the x, 3 is greater than x, you could read it backwards, x is less than 3. You just flip it around and read it backwards. That's your answer, which would be negative infinity to 3 with a parenthesis. This is also an answer in interval notation. And then example C, again, you take that what's inside your logarithm, let's say x minus 1 squared. Okay, now there's a way we can handle this a little easier. Remember, whenever your argument is raised to a power, you can move that number in front. So actually, we don't only have to do that since it's squared. You know what? It's always going to be positive. So the domain there is negative infinity to infinity. Now what we're thinking about really is x minus 1 squared is greater than 0. But what I'm trying to say is that's always true, because when you square something, it turns positive. You could solve this by factoring, which would be x minus 1 times x minus 1 is greater than 0. Then you do your number line. Okay. Actually, there's a number I forgot about, right? What if we plugged in 1? It wouldn't be greater than 0. So we'd have to take 1 out, but everything else would make that true. So actually the domain is negative infinity to 1 union 1 to infinity. Almost got myself in trouble there because I forgot about what if we plug in 1 because it can't equal 0. So for this problem, we're supposed to use the inverse properties of logarithms. So when I look at problem A, the natural log of e to the 6x, y'all remember natural log and e cancel each other out. They give me just regular old 6x. Question B, e to the natural log of the square root of x. Once again, the e and the natural log cancel out and give me a result of square root of x. And finally, C, 10 to the log. Now notice there's no base with that log, so that's really base 10 of 4x squared. What happens? The log and the log base 10 cancel to give me 4x squared. Next, I'm supposed to expand. So notice expand means we're supposed to write this as more than one logarithm. Remember, multiplication means addition, division means subtraction, and if you have an exponent, you pull it in front. But look, can't pull this 3 in front right now because the 3 only applies to the x. So we have to handle our multiplication first. So this is going to be log base 6 of 36 plus log base 6 of x to the third. Catch that? Again, the whole thing's not raised to the third, just the x. So I do addition first. Now, I can rewrite log base 6. I can rewrite 36 as 6 squared plus this 3 can move in front of the logarithm. So 3 log base 6 of x. But what happens here is the log base 6 and the 6 cancel. So the most simplified version of this is that last one, 2 plus 3 log base 6 of x. Next problem. Log base 4 or square root of x over 64. Division means subtraction, right? So log base 4 of the square root of x minus log base 4 of 64. Now the square root of x is really an exponent. So this is log base 4. Well, the square root is really an exponent. It's x to the 1/2 power, right? Minus 64 can be written with a base 4. So 64 is 4 to the 3rd power. Over here, this 1/2 exponent can be moved in front of logarithm. And here, the 4 and the base 4 cancel each other out to get minus 3. Okay, so I'm expanding again. Notice multiplication and division. So I've got log base 2 of x multiply, so plus log base 2 of y squared. Now minus, because we're dividing by the 64, so log base 2 of 64. Next will be time to pull exponents in front. So this 2 is going to go in front of the logarithm. And 64, I can write with a base 2. So I have log base 2 of x plus, move that exponent in front, 2 log base 2 of y minus log base 2. Now 64 is 2 to the 6th. So those cancel. We're using the inverse properties of logarithms, and I get minus 6. Final answer, log base 2 of x plus 2 log base 2 of y minus the number 6. All right, next problem. Natural log of the cubed root of x over e. It's almost hard to look at that one. I'm going to rewrite it. Natural log of the cubed root of x over e. Like that. Now this cube root, I can write that as x over e to the 1/3 power. Notice the parentheses. Why? Because the whole thing was the cube root, so that means the whole thing's to the 1/3, which also means that I can move the 1/3 in front. So this is 1/3 natural log of x over e. Notice how we move the exponent in front first this time, because the whole thing was raised to the 1/3. Now I can split this up as subtraction, so it's 1/3. Now I'm going to put some brackets here, because when I split this up as subtraction, that 1/3 applies to both of them. So if I leave that off, it looks like I'm only multiplying the 1/3 times the natural log of x. But it's also times this minus natural log of e, which, by the way, those cancel and give me 1. So final answer, 1/3 natural log of x minus 1. Or you could distribute the 1/3 inside, 1/3 natural log of x minus 1/3. Both of those are correct. You don't have to have them both to get it right. Next, these problems say condense, so we're doing the opposite. When you condense, you're trying to write the problem as a single logarithm, just one logarithm in your problem. So here we go. Addition, remember, means multiplication. So this is log base b of 7 times 3, because it turned into a multiplication problem. which we know that's log base b of 21 completely simplified. And once again, we're supposed to condense, so my goal was to write this with one logarithm. But listen, y'all, if there is a number being multiplied by your logarithm, you have to handle that first. That 3 times that log, that 3 has to go up as an exponent. So we have log 3 minus log x to the third, like that. Okay? And then now I need to divide. So they're both the same base 10. So I say log of 3 divided by x to the third. And you could put parentheses around that or not. It would still be right because you're taking the log of all of that. I like the parentheses because it's a little easier to tell what's going on. And here we go again. We've got numbers in front of our logarithm, right? So I have to pull that 3 up first and pull that 4 up first before I'm allowed to combine these together as multiplication, because remember, addition turns into multiplication. So do that. Don't do it all at one time. Do steps. So it's natural log of x to the third plus natural log of y to the fourth, right? So pull those guys up first. Then write that as multiplication. So that's natural log of x to the third times y to the fourth. And that's your final result. Here we go again, right? I have an exponent, right? Well, I have a coefficient in front of my logarithm, which is an exponent. So I'm going to take that up there as an exponent. That's the natural log of x to the 1/2 minus the natural log of y. We know minus means divide. So I write this as one logarithm. You don't divide two separate logarithms. It's a single logarithm. And what you're dividing is the arguments inside. So there we go. Now, if you wanted to take this an extra step, because you remember that 1/2 is a square root, and you could put parentheses around it, that's okay. But unless it said you had to write your exponents as radicals, you could leave it like this. Either one of these answers is appropriate. So let's use natural logarithms in a calculator to evaluate to 4 decimal places. So when I look at A, we have log base 6 of 72,348. Now, again, if you have a calculator that has a button like this on it, then you could type that directly in your calculator. But even if you do have one of those calculators, I'd like you to know the change of base formula. So you could change this to both natural logs. This value goes inside the numerator natural log, and the base value goes in the bottom. So that's what you would type in your calculator. The natural log of 72,348 divided by natural log of 6. Remember to close out the parentheses after the 72,348, and then you hit your next natural log. You've got a new set of parentheses you close out after the 6. And I get 6.2448. Okay, now for the next one, for B, again, I'm going to use my natural log. So it would be the natural log of 0.863 divided by the natural log of base on the bottom, 4. So what's going to happen is I hit the natural log button and parentheses will pop up. In my calculator, I need to close that out before I divide by the natural log of 4, and that one will pop up and I close that one out as well. So I have natural log, and again, parenthesis pops up, 0.863, close out that parenthesis, and then divided by natural log 4. And I get negative 0.1063 as my answer. Alright, natural log of x times the natural log of 1 equals 0. We're supposed to determine is this true or false. You need to be able to explain either way if I ask you about a true or false. And this one's actually true. But why do I know it's true? Okay, well, natural log of 1, we know by our properties, is 0. And anything times 0 gives me 0. So this checks out. Okay, so we use properties of logarithms for logarithm of 1, and we use the fact that anything times 0 equals 0. So it's multiplication property of 0. All right, next, we look at that. Again, you're trying to decide if it's true or false. Now, if I don't look at the right side at all, and I just simplify the left side, that is a condense problem, right? So I'm trying to condense this. That Subtraction means division. And I write x plus 9 divided by x plus 1 inside a single logarithm. So what's up with this extra logarithm down here? It does not belong, and you're taking the log of all that. So this one is definitely false. What was written on the right side over here is definitely not the same as when we condense it on the left side. Two separate logarithms there. They are not the same. And so didn't we just do this problem? we don't have to do it again. I get rid of that slide. Okay, here we go. There's a new problem. So, what do you think? Log base 2 of x to the 4th power, is that the same as 4 log base 2? It's actually not. So log base 2 of x to the 4th means 4 of them. That's log base 2 of x times log base 2 of x times, you get the point, log base 2 of x times log base 2 of x. It's not 4 of these. If we were adding, it would be 4 of them. Now, so this is definitely false. But what they have this confused with is if you had log base 2 of x to the 4th like that. That's not the same thing. This is saying every bit of this is raised to the 4th power. This one is saying only the x is raised to the 4th power. And in this case, you can pull the 4 in front. This is equal to 4 log base 2 of x. But that's not what you were given, right? You were given the 4 on the outside of the logarithm, and that's not the same. So this answer is false. This is maybe what they were trying to trick you with. All right, and the last problem for this particular video, determine whether each equation is true or false. Once again, are these the same thing? Yeah, that's true, right? Because the only thing being raised to the x power in this case is the e. That whole thing is not in parentheses like the last problem. So you are allowed to move that x in front. X times natural log of e. Forgot to write the n. There we go. Is definitely equal x times natural log of e. They're the same. Now it turns out that's just x, right? Zoom. No. That's just x. So these cancel, and that gives me x. But it didn't even ask that. It just asked if these were true, and they are definitely true. All right, I hope this helps you out. Please let me know if you have any trouble with this, or if you found an error. I'll be happy to find out about it and happy to fix it. Have a good one.